So welcome back, and we are continuing with our study of fractions, and today we're going to be talking about multiplying fractions, right? So we're actually on page 87 of our workbook, and let's take a look at what that looks like. All right, so overall here we've got some bits of this shape that are shaded, and if we have to talk about the total shaded area, in other words the dark and the light shaded, well, we can see that this is divided into fifths, okay? 1, 2, 3, 4, 5 columns. And 2 of those 5 columns are shaded. Okay. Now, if we now talk about what proportion, so we're going to ask you just to forget about for now this piece of the diagram. And if we had to say to you, what proportion is black of the stuff that's left? How much of it is black? What fraction? Well, we can see this is 1/3, 2/3, 3/3. So in fact, 1/3 of the shaded area is black. Okay, so let's just now rub that out. Okay, 1/3 of the shaded area is black. There it is. Then if we had to say to you, what fraction of the whole shape is black? Well, it will be 1/3 of the 2/5. And 1/3 of 2/5 means 1/3 times 2/5. And if we look at the answer is just 2 out of a total of 15 squares are black. Right, now you may or may not have understood that. Maybe you want to think about it again. But what we've established is that when we multiply fractions, we multiply the tops and we multiply the bottoms. We do not need common denominators. We just multiply the tops and we multiply the bottoms. So let's just do a couple of examples. 2/3 times 1/7. 2 times 1 is 2. 3 times 7, 21. 1/5 of 3/7 in fraction speak of means times. So 1/5 times 3/7. We're going to multiply the tops, 3. We're going to multiply the bottoms, and we're really hoping that none of you has a difficulty with 5 times 7, 35. This is the answer in simplest form. Those numbers are relatively prime, no possible simplification. Let's do the last one. 3/8 times 2/6, 3/8 times 2/6. Multiply the tops, we get 6. Multiply the bottoms, we get 48. That is correct, but it's not complete. All right? In order to complete it, we've got to try and see what numbers could divide into both of these things. You might say, oh, Paul, what about 2? 3 out of 24. Yeah, you would be right. Okay? That's still not as simple as it can be. Does 3 divide into 24? How do we test for divisibility by 3? Yes, we add the digits, 2 and 4, we get 6. Yes, 3 divides into 24. 24 divided by 3 is 8, and 3 divided by 3 is 1. If we were wide awake, we could have gone straight from here to here by dividing the top and the bottom by 6. Okay, but there it is. Okay, so what's interesting now is that sometimes it makes sense to try and simplify a bit before we multiply, right? So 12 times 25, that's not going to be all that easy to work out necessarily. But you might say, I can see something here. We could divide the top by 12 and the bottom by 12. And likewise, we could divide the top by 25 and the bottom by 25. And now we've got 1/1 times 2/3. We've got 1/6. 1/6 is the final answer to this. Okay, and you might say, but my calculator can do it. Your calculator can do it, but you need to be able to do it, right? And you need to be able to do it without a calculator, because later when we do algebra, we're going to do algebraic fractions, and if you don't understand normal fractions, then algebraic fractions are going to become a problem. Right, now, let's look at this. We could multiply 19 by 8 and 56 by 190. Those are not easy numbers to multiply. We could use a calculator, but let's see if we can't do some simplifying first. Can we divide that by 19 and that by 19? Impela. 19 divided by 19, 1. 190 divided by 19, 10. Does 8 go into 56? Could we perhaps divide the top by 8 and the bottom by 8? 8 times what gives us 56? 7. 56 divided by 8 is 7. And now the final answer to this one, we've just got 1 times 1 on the top, and we've got 7 times 10, we've got 70 on the bottom. Right. Very often you may hear even teachers talk about cancelling. All right. We don't really like the word cancel. All right. 4 times 3, for example, over, let's say, 12 times 4. Right. So sometimes people will say, oh, we can cancel these 4s. Right. We don't like that term. The reason we don't like the term is when you cancel something, there is nothing left. Luto. Whereas here, there's actually a 1. We are dividing the top by 4, and we're dividing the bottom by 4. Right. And so our answer here would be 3 over 12. Can that simplify further? Yes, because we can divide the top by 3, goes in once, and the bottom by 3, it goes in 4 times, and there's our answer. Okay. Now, we're going to talk about a kind of a quick rule for converting what we call a mixed number, so that's got a whole number part and a fraction part, to an improper fraction. Now, you may well have learnt a method, okay, and it's written down here. You multiply that by that, and then you add that. Now, that's sort of a clever trick. So, in other words, the final answer, 3 times 5, 15 plus 2, 17 over 5. Okay, and this one, 4 times 3, 12 plus 2, 14 over 3. Now, tricks are well and good, but we need to understand why they work. Let's go back to what does 3 and 2/5 mean? It actually means 3 plus 2/5. Right? Now we want to add these two fractions. So what in fact is 3 as a fraction? It's 3 over 1. Now, what fraction type am I going to use if I'm going to add these two? Absolutely, I'm going to use fifths. Right? These 2/5 are ready to go. Right? 3 over 1 is not in fifths. What must I do to this denominator to make it 5? I must multiply it by 5. So my answer is going to be 3 times 5 plus 2. That 3 times 5 over 5 is what 3 is equal to, and 2 over 5 is there. All right, and now we can see why that little rule works, and we get that answer. Right, let's do 4 and 2/3 and just explain why. Once again, just watch carefully. 4 and 2/3 actually means 4 plus 2/3. Okay, 4 is 4 over 1. I want to add these two fractions. I'm going to get them both to a denominator of 3. This one's already got a denominator of 3. What must I do to the 4 to give this fraction a denominator of 3? Well, I've multiplied the bottom by 3. I must multiply the top by 3. And I get 4 times 3. And now they're both of the same type of fraction. They've got a common denominator, and I can add them. And now we can see why that little trick works. When we multiply the 4 by the 3, what we're actually doing is we're working out how many thirds is 4 equal to. And 4 is actually equal to 12 thirds. Plus these other 2/3, 14 thirds. Okay, now we don't ever multiply fractions or add them or do any operations with them when they've got mixed numbers. We always change to improper fractions. We're going to ask you to pause the video, and we're going to ask you to try all the questions on this page. Then when you've done them all, we're going to ask you to let it play again, and we will then show you the solutions to them. Okay, so let's take a look. Now, again, it just pays to look before we leap. Before we do this, we can actually divide the top by 3 and the bottom by 3. Final answer, 2/5. Many of you probably didn't spot that. You probably went 6 over 15. 6 over 15 is not incorrect, okay? But it's not as simple as it can be. What can we divide both 6 and 15 by? We can divide them both by 3 and then we get 2/5. There's our final correct answer. 3/11 of 22 over 50. Let's change the word of to times. Okay, now our lives will be easier if we realize that in fact we can divide the bottom by 11 and the top by 11. 22 divided by 11 is 2. We're now going to get 6 over 50. 6 over 50 is an answer. It's not our final answer because 6 and 50 are not relatively prime. We can divide both the top and the bottom by 2 and we get 3 over 25. 25 does not divide by 3, and so that's as simple as it can get. 2/5 of 60. Remember, 2/5 means 2/5 of 60 means 2/5 times by 60. I just want to draw your attention that that equal sign means that the stuff is exactly equal to the stuff above it. Right? Now, we need this to be a fraction. This is 60 over 1. Right? Now, we could do some simplification here because, in fact, 5, we can divide the bottom by 5 and we can divide 60 by 5 and it goes in 12 times. Final answer here, 24 over 1. We wouldn't write 24 over 1. We just write 24. Okay, this next one, okay, once again, we could do some simplifying first, right? Because we could divide the top by 3 and the bottom by 3. So our final answer is going to be 5, and 5's prime, so we don't need to worry about looking for any other possible factors. 5 over 4 lots of 6, 24. There it is. That's as simple as it can get. Okay, and then the next one. 3/5 times 2 and 1/3. Now we're going to be very careful here. Before we can do anything, we must change the 2 and 1/3 to 2 times 3 plus 1, 7 over 3. Right, now this is quite straightforward because the 3's can divide out and we get 7 over 5. 7 over 5 is our final answer, all right? Or we could write it back. 5 goes into 7 once, and there will be 2 left over, and those are 2/5. This is the undoing of taking 1 and 2/5 to 7 over 5. 7 over 5, 1 and 2/5. 3/5 of 7.5. We're going to, so I left off my equal sign here. We're going to change the of to a times. We are also going to change the 7.5 to an improper fraction. 7 times 2, 14 plus 1, 15 over 2. Now, we can multiply and then simplify. All right, here what we're actually going to get, we're going to get 45. 3 times 15 is 45. And on the bottom, we're going to get 10. Now, this can simplify because these are both multiples of 5. 45 divided by 5 is 9. 10 divided by 5 is 2. 9 over 2. All right, 9 over 2 or 4 and a half. 4 lots of 2 is 8, so 4.5. Okay, the next one, we've just got to be very careful. Do we remember our order of operations? Should we add these two things or multiply these two things first? And the answer is that we do need to do the multiplication first. So let's multiply 1/3 by 3/4. Rather than multiplying first, let's simplify first. We can divide by 3 and we can divide by 3. So in fact what we're trying to do is we're trying to add 2/3 and 1/4. Now, we cannot add things when they're of different types, so we need to find a common denominator, something that 3 and 4 both go into. Ideally, we want the smallest number. So you might say 24, and you would be right, but 12 is smaller still. So let's change the 2/3 to 12ths. and the quarters to twelfths. Now remember what? We're only allowed to either multiply or divide by the same amount. What if we multiplied 3 by to get to 12? By 4, so we must multiply the 2 by 4 and we get 8 twelfths. What if we multiplied 4 by to get to 12? By 3, so we must multiply the 1 by 3. 3 twelfths is exactly the same as a quarter. 8 twelfths is exactly the same as 2/3. This blue line is exactly equal in value to this yellow line. Okay, the only difference is that in the yellow line we've got the same type of thing, so we can add them. If we've got 8 things and we add 3 things, then we've got 11 things, and those things happen to be twelfths. Does it make sense? It always makes sense. Right. 3/5 of 8 and 2/5. So what we're going to do first is we are going to change the of to times. We're going to change the mixed number to an improper fraction. 8 times 5, 40 plus 2, 42 over 5. Right. Now there's no simplification that can happen here, and we actually get 3 times 40 is 120, 3 times 2 is 6, 126 over 25, and that's as simple as that can get. Okay, 3/4 of 8 1/4. Once again, we're going to write 3/4. We're going to write it as times. We're going to change 8 1/4 into an improper fraction, 33 over 4. Final answer here, 4 times 4 we know is 16, and 3 times 33, 99. It's quite easy to see on this line that there are no common factors, all right, because nothing goes into 3 and 4, all right, and nothing goes into 33 or 4. Okay, and then this last one, we could do some multiplying and then some simplifying, or we could do some simplifying and then some multiplying. I'm going to show you both. If we multiply 4 by 3 by 5, we get 12 times 5, we get 60. If we multiply 2 by 9, we get 18. If we multiply 7 by 18, okay, 7 times 10 is 70. I think we're going to get 126. Okay, I think that's what the answer is. I'm going to just quickly check myself here. Okay, so 7 times 2 times 9, 14 times 9. Sorry, we're not on the calculator here. 14 times 9, 14 times 9, 126. Okay, now we could simplify. All right, these are both even, so 30 over 63. These are both divisible by 3, so if I divide by 3, I'm going to get 10, and I divide by 3, I'm going to get 21. Now that's the answer. I'm going to show you that it's much easier not to do it like that. It's much easier to simplify first. Let's divide the top by 3 and the bottom by 3. 9 divided by 3 is 3. Let's divide the top by by 2, and we get 2, and the bottom by 2, and we get 1. And now on the top we got 2 times 1 times 5. 2 times 1 times 5 is 10. All right, and on the bottom we got 7 times 1, which is 7 times 3, we got 21. Okay, I think you're right. I think you'll agree with me. That is much quicker. Okay, we're going to stop there, and we look forward to seeing you next time. Have a great day, everyone.